All right, so how do we think about a Wittig reaction retrosynthetically? So how do we disconnect a molecule to different starting materials? Well, wherever the alkene is, that's where we cut the molecule. And essentially, Wittig is mixing a carbonyl with an ylide. So we kind of have two options here. So option A would be, let's make the carbonyl on this side, the ylide on this side. So if we did that, we would have the carbonyl right there. The ylide would be right here. If we decided to do the opposite, we would have the ylide as this piece. So look like this. And then the carbonyl, so I'll draw a line between them to show the difference. The carbonyl right here. And one thing we have to consider is, well, how simple will ylide synthesis be toward preparation of the starting material reagents to make this product? So essentially what I want you to do now is one of these routes is probably going to be a little bit better than the other. So work through what it would take to synthesize this ylide versus what it would take to synthesize that ylide, and then restart the video. And I'm actually going to write a little bit up here, so take a minute to do that. All right, so you've already got your ylide synthesis methods up. Hopefully it looks something like this. To synthesize this ylide, we would take an alkyl halide, do an SN2 reaction, and then the acid-base chemistry. To make that ylide, we'd take this alkyl bromide, do an SN2 reaction, followed by the acid-base chemistry. So that would make ylides A and ylide B. But which one of these is going to be the more efficient pathway? Because as organic chemists, we always want to get the highest yield. We want to do the most efficient reaction. Which one is going to give a higher yield, would you say? Yeah, so that really comes down to what is the competing reaction with substitution chemistry, and that's elimination chemistry. So which of these alkyl halides is more open for an SN2 reaction? And that really comes down to the steric hindering of the backside of the alkyl halide bond. So essentially, triphenylphosphine, is it going to have better access to the backside of this carbon-bromine bond or the backside of this carbon-bromine bond? And hopefully you can see that with a secondary, this is a secondary alkyl halide, it has more stuff kind of blocking that backside of the carbon-halogen bond, whereas this is a primary alkyl halide. So the SN2 chemistry is just going to be more favorable with this alkyl bromide down here. So this would be the better pathway to give us a higher yield of our ylide that we would use in the Wittig reaction. So the better pathway towards that would be through B, option B. So yeah, be thinking about how efficiently things can be synthesized, and that would lead you to your better retrosynthetic pathway.